Okay, so I didn't realize that the video had gotten cut off, so we're continuing to where we left off in the previous video, where we finished to remove the smallest exercise. We're moving on to the Sudoku print out the grid and add a number exercise. We're told that in this exercise we'll complete two more functions for the Sudoku project from the previous section, print Sudoku and add number. The function print Sudoku takes a two-dimensional array representing a Sudoku grid as its argument. The function should print out the grid in the format specified in the examples below. The function add_number takes a two-dimensional array representing a Sudoku grid, two integers referring to the row and column indexes of a single square, in a single digit between 1 and 9 as its arguments. The function should add the digit to the specified location in the grid. So if we had this matrix for our Sudoku defined, when we call the print Sudoku function and pass the Sudoku to that function, this is what it should print out, right? So it will be 9 blocks and separated into 3 blocks per group. Then when we call the add number function, we pass the Sudoku, provide the indices, followed by the number that we want to put at that index, at that position, right? We do that 3 times. Now when we print the Sudoku again, this is what it should print out. So here we have some hints. Remember, it's possible to call the print function without using a line change, right? When we pass the second argument with the end equals empty string, and then without carriage returns as well. So this will print without creating a new line between the two print statements. And when you do need a new line, you just use the print function and don't pass any arguments. So let's go back to VS Code. We will close these 2 folders. In fact, let's collapse everything so we only have one thing open at a time. So what I'm going to do is, first and foremost, I'm just going to copy this. Then I'm going to define the function print Sudoku, which takes in a Sudoku, which is of type list. And I'm here also going to define add number function, which takes in the Sudoku, the row number, the column number, and the actual value that we want to put there. And this is very, very, very easy. Since we're given the Sudoku, we're given the row number, the column number, and what we need to do. All we got to do is just write Sudoku, target the row number and the column number, and set that equal to number. So that's just that function. I think that's pretty easy and pretty straightforward. This one might be a little bit more complicated. We're going to need some loops here. So we're going to do for row in range 0 to 9, and for column in range 0 to 9, right? Because each Sudoku grid is 9 values wide and 9 values tall. So each row will be starting from 0 to 9, and each column will be from 0 to 9 as well. Then we're going to say if Sudoku at that row and column has a 0, which means it's empty, then we'll print that underscore followed by an empty space. Otherwise, we'll just print whatever value is there and concatenate it with that open space. So this is if we have a Sudoku and like this, and it's not filled in, right? There's no 1s, there's no 2s, 3s, 4s, 5s, 6s, 7s, 8s, or 9s, right? It's all zeros, indicating it's all empty spaces. Then print out the underscores that we see here. Right? Print out these underscores. Otherwise, if there is a value, then print that value and then print the space. Now, each every 3 columns, as we can see here, there's a, right, we get 1, 2, 3 columns, and then there's a space, another 3 columns, and then a space, so we need to also do that. So here we say if column, we're going to do the modulo operator, pardon me, column does not equal 8, because we're starting counting from 0, right? So 8 will be position 9. So this will be 0, 1, 2, 3, 4, 5, 6, 7. I'm sorry, 0, 1, 2, 3, 4, 5, 6, 7, 8. This will be our last column, so we don't want to add any spaces here because it will be after 3 columns again. So we don't want to add any spaces here. That's why we say end column is not the last column. Then we're going to do is just print an empty space and not and end like that, and we're not going to add anything to, there's not going to be any carriage returns. We just want to print everything in once. Put that space and then continue printing what comes after. Then we're going to back up. We're going to print a new line. So this is basically going to do 1, 2, 3 space, 1, 2, 3 space, 1, 2, 3, and then come to the next line and do it over again. But after we do all of that, we need to also print a space between every 3 rows. So what we're going to do is say if row, and basically do the same thing. %3 is equal to 2, and row does not equal to 8, right? It's not the last row. Then we want to print an empty line like that. So it prints an empty string here. And that should be it. So now, this is going to print quite a lot of stuff. Let me clear this. Let's run this and see what happens. And there we go. So we have our Sudoku grid printed exactly how we want it. 1, 2, 3, 1, 2, 3, 1, 2, 3, and then 1 row, 2 row, 3rd row, space, another row, another row, another row, space, and then the remaining 3 rows. And then when we call the add number function and we tell it to put 2 at position at the first box, so it adds the 2 here, add the number 7 at row 1, column 2, so row 1 will be the 2nd row, and position 2 will be here, right? 0, 1, 2, so we put a 7 here, and then put a 3 at which would be row 6, and this will be column 8. We put the 3 here. So that's what's going on here, and we have everything printed correctly. So when we run this through our tests, should go through without a problem, and it does. We can send that solution to the server so we get credit. Go up here, refresh, and we do get credit. And we can also take a look at the model solution. And there we go. So they do a lot of abbreviations. Yeah, and this might even be just a little bit better because, right, instead of creating a new using the range functions, we can use the Sudoku itself to iterate over the rows, and then we can see that if the position that we're in is 0, then print that value, right? Otherwise, keep going. So that means if the character at a specific cell had a value that wasn't 0, then we'll just print that value. Again, I don't like using abbreviations like this because it just makes it a little bit harder to read, but they do the exact same thing here, right? If we're not at the last row and we're at that dividing position, like what is it? When we at this position here, then print that empty space for the columns, and then do the same thing for the rows. So this is the model solution, and the add number function is exactly what we wrote here. So yeah, par for the course. I think this might be a little bit easier on the eyes to read and follow, but if you prefer this, you can copy this and just study it. But this is our solution. But yeah. Okay, we have another exercise here called Sudoku add number to a copy of the grid. It says this is the very last Sudoku task. This time we will create a slightly different version of the function for adding new numbers to the grid. The function copy and add takes a 2-dimensional array representing a Sudoku grid, 2 integers referring to the row and column indexes of a single square, and a single digit between 1 and 9 as its arguments. the function should return a copy of the original grid with the new digit added in the correct location. The function should not change the original grid received as a parameter. The print Sudoku function from the previous exercise could be useful for testing, and it is used in the example below. When dealing with nested lists, you should be extra careful when copying what all needs to be explicitly copied and where the changes actually have an effect. The visualization tool can help. So what I'm just going to do is I'm going to copy this. I'm going to go to VS Code, go here. I'm going to keep this open for a second because we're going to need it. If name is equal to main, then we're just going to print that, indent properly. Then what I'm going to do is I'm going to copy this print function because we're going to use it in here for testing. And we're going to copy this, but we're going to change it just a little bit since we're not going to need it exactly. Or we might keep it because it's something we might experiment with. But I will duplicate this line, copy and add. So what we're going to do here is create a list called clone, set that equal to an empty array. Then we're going to say for sub list in Sudoku clone.append sublist, like that. Then we'll do cloned at row number and column number, set that equal to number, and then we'll return cloned. So now when we run this, we get original, which prints the empty grid, right? Because our original Sudoku was this empty grid. And then we created a copy and added the value 2 at index 0, and it's displayed here. So one thing I was curious about was see if maybe we could do cloned is equal to add number, then pass cloned, pass row number, column number, and number, and then see if this will still work. All right, it won't work because we're not returning anything in this one. We're just updating it. So we might have to do this maybe. There we go. So let's run this. And it also works. So you can do this. You can submit all three here. The print, add number, then use the copy and add. Use the add number function inside the copy and add so we don't manually have to do it again. In fact, let's submit this and see what it does. It still worked, so we can send that solution to the server. Take a look at the model solution in the browser. There we go. They just define the copy and add function here, right? Create a new list, then append it, basically the same way that we did, and then update it, and then return it. So you can do it this way. You can also build on the previous two functions that we used in the previous answer, or you can do it again like we had it originally, where we do cloned at row number, column number is equal to number, like that, and then just return cloned. Either way works. Yeah, I think this is good because it shows that we're building on from previous exercises, and it also helps with separation of concerns. Remember, that's one of those things that we've talked about that sort of exists in the back of your programming mind as you continue to grow as a developer, right? Separation of concerns. You don't want a function that does multiple things. Usually you just wanted to do one thing and one thing only, so you can have a function that does add the number and then a function that just clones the list, but we can call the add number function and then return the cloned list. So either way works. I like it this way because it builds on what we just did and still keeps things neat and tidy, but you can also just do it the other way. All that matters though is this really in particular. So that's why you know, doing this might be a little bit better accepted. So cloned row number, column number is equal to number, right? This will be just if you wanted to submit. If this is the only thing they're really worried about in this exercise, so that's why. But for a solution that builds on everything we've covered regarding the Sudokus, then this is even that much better. So yeah, so we're down to the last two exercises, so we'll move on to those also in this video. Okay, so here we have another exercise called tic-tac-toe. Tic-tac-toe is played on a 3x3 grid by two players who take turns inputting nods and crosses. If either player succeeds in placing 3 of their own symbols on any row, column, or diagonal, they win. If neither player manages, it is a draw. Please write a function named playTurn, which takes a game board of type list, positions x and y, which are integers, and a piece, which is a string, places the given symbol at the given coordinates on the board. The values of the coordinates on the board are between 0 and 2. When compared to the Sudoku exercise, the arguments the function takes are the other way around here. The column x comes first and the row y second. The board consists of the following strings: empty square, x player 1 symbol, and 0 is player 2 symbol. The function should return true if the square was empty and the symbol was successfully placed on the game board. The function should return false if the square was occupied or if the coordinates weren't valid. An example execution of the function. So if our game board is empty, then we tell it to place an x at 2, 0. Then it should return true if it was a successful move, and then place the x here. Okay, seems pretty straightforward. I'll close this. If name is equal to main, define playTurn, which takes in a game board, x, y, and piece. So I'm assuming here we'll just do is if game board at yx is equal to an empty string and game board at yx is less than 2, sorry, this should be double equals, then we'll place the piece and return true, else return false. Okay, we got a problem. This be xy. Hang on a second. Okay, so this works and we get it placed in the same position. So while this works, we still need to take into account some constraints, right? It said the function should return true if the square was empty and the symbol was successfully placed. The function should return false if the square was occupied or if the coordinates weren't valid. So we need to also check if the piece wasn't empty. So if game board at yx does not equal empty, then return false. Then what we need to also do is check if the coordinates are still within the game board. So if x is less than 0 and x is greater than 2, or y is less than 0 and or y is greater than 2, also return false. Oh, I'm sorry, this is not a double equals here. Since those two first have to pass, then we can just do game board at yx is equal to piece and then return true, like that. So now all our conditions are met. First, we check that the coordinates are within the game board. Then we check that where we want to place our move isn't occupied, right? There's no x, there's no y. So if it's not an empty string, which means there's something there at that position, then return false. And if both of these pass, then place our piece and then return true. So let's run this. And there we go. It also worked. So we can test this. We failed, so make sure the function can be called with the following parameters. Okay, so let's do this. And let's call game board with 30x. Okay, we're getting an error. List index out of range. Yeah, this shouldn't work, so why is it? Right, because we've checked that it's not, if x is not less than 0 or greater than 2. Oh, I'm sorry, this should be or. There we go, false. There we go. That should have been or. I'll put an and here for whatever reason. Now this should work. There we go. Send that solution to the server. And we'll take a look at the model solution. And there we go. They did the same thing. They checked whether that's whether our desired move is within the board and that the position that we want to place our move is empty, then place our move and return true, otherwise return false. So they even shortened it just a little bit, right? They didn't check specifically if where we want to place our our piece is empty, right? So we could also do it this way and then set the piece and return true and have a final return false here. But this is also working, so we'll keep it as that. But yeah, both solutions are pretty much the exact same. So yeah, we can go back to the browser here, refresh, make sure we got credit for that, and we did. Did we also do the same thing here? We did. Okay. Okay, and here we have our final exercise in section 2 called transpose a matrix. We're told to please add a function named transpose, which takes a two-dimensional integer array, a matrix, as its argument. The function should transpose the matrix. Transposing means essentially flipping the matrix over its diagonal. Columns become rows and rows become columns. You may assume the matrix is a square matrix, so it will have an equal number of rows and columns. So the following matrix, which has the integers 1, 2, 3, 4, 5, 6, 7, 8, 9, transposed, will look like this. 1, 4, 7, 2, 5, 8, 3, 6, 9. The function should not have a return value. The matrix should be modified directly through the reference. So as you can see here, there's only one thing that stays consistent between the original matrix and the transposed one, and that is the value at the top left corner. So the first index stays the same. So that's one thing we need to keep in mind, which is going to make this a little bit easier to do. It means we don't have to transpose the entire thing, and meaning that, for example, if we were to do it, because if we were to start at the first index and traverse it, our list will end up looking exactly the same way. So here we're going to define a function called transpose. It's going to take in a matrix, which is of type list. Then what we're going to do is create a helper variable here called size, set that equal to the length of the matrix. Then we'll start looping. We'll say for row in range of size, oops, pardon me. And then for column in range, row plus 1 to size, declare a variable here called temporary, with temp, set that equal to matrix at row and column. Then we're going to start transposing. So we're going to say the matrix at row column is equal to the matrix at column row. So now take our matrix, our board, and at a row comma column, switch that to the column row equivalent. So if we had 0, row 0, column 1, then swap it to column 1, comma, row 0. Hopefully that makes sense. Then we'll do matrix at column row, set that equal to temp, like that. So we make use of the temp. So this is our temporary holder, right? That stores the current value. Then we transpose, and then we move that original temporary value to the where we transposed the row from. Hopefully that makes sense. And I think that should be it. I think that's is just taking another look here. Yeah, I think that should be it. So we could submit this, right? But if we want to see it in action, is equal to main matrix here. Let me go and copy this, paste it there. Comma here, do the same thing here. And do the same thing here. Make sure this is properly nested. We just keep it in line like that. Then print original, and we'll put matrix here. Then we'll run the matrix through the transpose function. And then transpose. There we go. When we started, we have 1, 2, 3, 4, 5, 6, 7, 8, 9. And now we have 1, 4, 7, 2, 5, 8, 3, 6, 9. So yeah. I'm just going to remove this. We don't need it. But this is the solution to this exercise. Send that solution to the server so we get credit for it. And I'll also open the model solution in the browser. And there we go. They did the exact same thing we did. The exact same thing that we did. But again, they just used these I and J reference variables instead of row and column, like how we did. But it works. Same solution here. And that's it. That's the final exercise in section 2 of part 5. Again, I'm sorry that the video got cut off. I meant to do everything in one video, but OBS, for one reason, decided to stop itself, so I had to come back and finish it. So let's finish this reading, and we'll be done with section 2. Side effects of functions. If a function takes a reference to a list as an argument, it will be able to modify that list. If direct modifications were not intended by the programmer, accidentally modifying the list received as a parameter could cause problems elsewhere in the program. Let's take a look at a function which is supposed to find the second smallest item in a list. Here we define second smallest, which is in our list, that returns an integer. In an order list, the second smallest item is at index 1. So we do mylist.sort, then we return mylist, right? We modified the list here by calling the sort function. And then we return that integer. So now numbers points to 1, 2, 1, 4, 2, 5, blah, blah, blah. When we print second smallest, it prints 2. But now our list, when we print it again, is no longer in the same order. It's been sorted from smallest to largest. So we modified the function. The function does find the second smallest item reliably, but it additionally sorts the list in place, changing the order of the items. If the order is significant elsewhere in the program, calling the function could cause errors. Unintentional modifications to an object accessed through a reference is called a side effect of a function. We can avoid side effects by making a small change to the function. So list copy is, we call a sorted function, pass the reference to the list here. So now list copy points to a copy of our reference list, and then we can return the second smallest value, like this. And our original numbers list will still have the exact same order. The function sorted returns a new sorted copy of the list, so looking for the second smallest item no longer messes with the order of the original list. It is generally considered a good programming practice to avoid causing side effects with functions. Side effects can make it more difficult to verify that the program functions as intended in all situations. Functions free of side effects are also called pure functions, especially when adhering to a functional programming style. This is a common ideal to follow. We'll explore this topic further in Advanced Course in Programming, which is the course following this one. You have reached the end of this section, blah, 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 blah. So you might be wondering, well, how can I avoid in the future unintentionally making modifications to variables, to data that I don't want to be modified within functions? Well, there's not really a way that you can see it in real time, right? Because there's just not a way to really do that. But the easiest way, as we've done multiple times when we're writing our solutions, is to test your program and see that it does exactly what you want it to do. So every single time you add a new function, run your tests, right? Run your program. See if everything is working up to that point. Nothing has been modified or changed in a way that might affect how your program functions. Now, sometimes you might be building out a really, really big program, so you don't really know whether or not whatever you've done can be consequential later in time, right? So the only other way to combat that is to start writing unit tests, start writing end-to-end tests, right? If you're writing a big program that does multiple things, or you're building like a website with a back end, so you want to make sure all functionality works, so you could write end-to-end tests. But unit tests are probably the best way to test your code on the fly and to make sure that your code is always doing the exact thing that it's supposed to be doing. So you write a function and write a test that tests that function specifically by providing values. And you make sure that the output is always the same, or whether it's formatted the exact same way, or formatting the exact same results, or it has expected results. So maybe your function doubles values in a list. So your tests will be able to input a list and then make sure that the return list, excuse me, has all the values within it have been doubled and nothing else, right? The list isn't sorted, it's not jumbled up if it was sorted. So yeah, writing tests, which I hope we'll learn either in this course or the advanced course, is one of those ways, especially when you're writing big pieces of software that a bunch of users are going to touch, or a lot of maybe you don't have individual users, but you have businesses that use your software. And so it's important that whatever data that they work with is always consistent. It's always the inputs and the outputs are expected to work the exact same way, right? So write tests, your code will run through those tests before you deploy changes or you ship changes that your customers will be touching. So that's probably the best way in the future to be able to do that. But in the medium sense, in the current sense, when you're writing small programs like what we're doing right now in our exercises, the best way to test to make sure that everything is working as it should be is to run your code and make sure that you get the expected output. Okay, so that's the end of this section. Let me know in the comments if you have any feedback. Again, take a look at the video that I posted down. It will be 2 videos ago now. Take a look and see if, what your feedback is. Should we continue making videos like we are right now, where we are reading the material on screen and then doing the exercises, or should we update our video format to where we just have the covered content will be the exercises, we'll write the solutions, We'll go over the model solutions. If they differ too much what we write, or if they're exactly the same, we'll just point that out, and we can keep them a lot shorter. The videos will be a hell of a lot shorter if we were to do it that way. And that way I can dedicate each video to each exercise to make sure that each exercise gets the right amount of attention that it deserves. So let me know. You can either leave that feedback in this video, you can leave it in the previous video, or the actual video in which I'm asking that question, which will be linked in the description below. Please make sure you go check it out. Your feedback means the world to me. Thank you to everybody who subscribed recently. Thank you for the comments that I've seen. Thank you for the likes on the videos. Let's keep moving forward. We're almost towards the end of this course. We're almost to the end of this section. The next section, we're going to start learning about dictionaries. Then we're going to learn tuples. And then we'll be done with section 5. Part 5. We can move on to part 6, which also only has 4 sections. And part 7, which has probably among the most amount of sections. And after that, when we're done with part 7, you can go on and take the exam to get your certificate of completion. And then you can move on. You can do the advanced course as well if you'd like, or you can go and take on another course. But that'll be the end of this follow along playlist. If you'd prefer, we also do the advanced course. We can start doing that as well. But I will probably move on to some other stuff related to. But if you guys still want Python videos, let me know. We can learn how to make a server in Python, right? To make back ends with Python, create full stack applications with a Python backend and Django. So let me know. There's a lot that we can do. We can do TypeScript tutorials, even though there's a whole billion of them and so many creators doing that, but it's popular content, learning modern technologies. So let me know. The world is our oyster after we finish section part 7. But yeah, we're done with section 2 in part 5. Next video, we'll start section 3. And then hopefully be done with section 4 by the end of the week. And we can start part 6.